rate is actually given in steps at time at end format, and then these are the values given. But here one more change is there. This time PVT parameters will not be considered as default, so these values are given to us. Okay, so we will use the same value which are given to us, and then there is no hint about the even problem. So what is actually the objective? You have to make the diagnosis and then adjust the model accordingly, try to find the best answer. Okay, and then any comments about the model parameters values. So this is the description of the problem. So we'll see how can we diagnose the problem and then find the best answer from the model. Okay, so what I will do, I'll share my desktop now. It's not working. There is some problem. Please wait. Yeah, I'm able to share my desktop now. So I'm going to start the Eclipse software. In this again, I'm going to load the Sapphire model. One minute. New description. The well radius was given to us is 0.2291, and here well radius is 0.3, so I will change 0.2291, and page on is actually 500 feet, so I will take 500. Now porosity is 0.14, so we'll take 1.14. Okay, now this time about the reference time, nothing has been mentioned, so we will take the default values here. So click on next. Then the PVT parameters, yes, you can change because what formation volume factor is given as 1, but the viscosity is actually the 0.80639. So I will change this 80639, then 3.408 e raised to the power minus 5. So these were the values of the PVT parameters. So I have taken the same values in the model, then click create. So in this, now I can actually load Q. So I'm going to load Q now. So I have the rates here. So click next. Then it is already actually in the free format, but you have to take steps time at end. Okay, and it is already in the free format, so no need to change anything. We will load this. Yeah, then load P. This is also in the fee format, so we'll load the same. So now this is the pressure and the rate history plots. Are these plots visible to everyone? Yeah, are these plots visible? Okay. Now, again, look at the data carefully. In this, I can see there is one buildup here, another pressure buildup is here. So based on the pressure data, I can say one pressure buildup data is here, and this one is very established pressure buildup data. Okay, so we have actually the two pressure buildup data, PBUs. One you can clearly see has a problem and it cannot be synchronized. So it may be because of the sensor problem. But the second one, we will use the second one to diagnose the reservoir. But let us see, is it synchronized or not? So you can see it is very well synchronized. Okay, we'll take this value. Yeah, and go with the interpretation. Extract DP. So yeah, it has again the pressure buildup one or choice for the pressure buildup two. So I'm taking actually buildup two. And these values I will take as default. So now this is the pressure derivative current. Okay. So is this visible to everyone? Pressure buildup curve, border derivative. Yeah, is it visible? Is that visible to everyone? Okay. So let us see what could be the interpretation of this pressure derivative curve. So in this, I can clearly say that there is a pure wellbore storage. But after that, let us confirm this also from the storage line. So you can see wellbore storage is there. Then I have to now make guesses here because this line seems to me like it can match with the spherical flow. So let us try the spherical flow. Where is the spherical flow? You see, this line is also matching. This one is also showing. So you can consider this as here as a spherical flow. This is also matching. So I am considering this is spherical flow. IARF is also look visible. So let us confirm the IRF also. So it is also there for a small time, but I can see that there is a like boundary effect also. So in order to confirm this, I can make some guesses. The graph goes up. We know this could be the case of the pseudo steady state. This could be the case of the fault, and then only you will see our closed system. You will see. So let us confirm the slope of this graph. Fracture. No. Let us confirm the channel. Yeah, this slope is higher than the channel slope. So this one is higher. So let us see if it is behaving like a closed boundary. So I can see yes. This one is matching with the pseudo steady state slope. Okay, this one is matching with the pseudo steady state slope. So these are some of the interpretations which I'm trying to actually apply here and trying to actually diagnose the graph. What could be the possible reason and what could be the possible interpretation of this? So if you want me to apply any other thing, I can again apply. If you have any other guess, so you can let me know. I can again change and I can apply another line here. So well-bore storage is confirmed. Spherical flow was also looking possible, and this one also showing the pseudo steady state slope. So this was in the LTR, or the boundary effects were visible. Okay. Any question, anything if you want to discuss, you can let me know. This is actually the MTR line. Now we'll go with the model. So in model, now actually, because nothing was actually clear from the description, therefore everything was actually hidden in this description. It was asked that you have to actually diagnose and select the model, which one is giving the best fit. So I'm going with the basic one, that we have a constant well-bore storage. Yes, then well could be considered as, because it was showing the spherical flow. So let me take the, because it was showing the spherical flow. So the first guess says, let us take the vertical limited entry well. So I have chosen the limited entry well. Then in limited entry well, I am taking the reservoir as a homogeneous model, and boundary model I can consider as a circle, because it is showing me the slope of 1. So usually slope of 1 will occur when we have the closed boundary and it is giving the pseudo steady state slope. Okay. So based on the character of the graph, I'm making changes in the model. And then here also, if I'm considering the limited entry well, then you can see the schematic. Is this schematic visible? So in this schematic, okay, in this schematic, I can see HW is here, ZW is here, and H is this. So can you, yes, in HW, it is the model is proposing HW as 250 feet, ZW is 250 feet. Because in description, if I go with the description, nothing was given to me. So I will take the default values, because anyhow, the simulation will take care of these HW and ZW value also. Okay. So let us generate. So what I'm getting this type of graph here. Yeah. So this one is not matching, and particularly in the last LTR zone, I'm not seeing any possibility of match. Even you can see the MTR graph also. So let us try to improve it. So now you can see here in the model also, when you run the simulation, you can actually take the constant value if it is given. So if I'm going to actually remove this, then you can feed the constant value here. Something, if you want to change it, suppose you have some value, so you can change it. Otherwise, if you click on this, the model is going to run simulation on this also, between 25 and 2500 feet. So because nothing was, yes, I have a question here. Sir, did we specify? Yes, Amir. I'm saying the same thing because we did not specify ZW and HW. So therefore, the same information was also not given in the description. If you look at the description, nothing was given to me. But what was actually suggested? Make the diagnosis and adjust the model. You have to actually find the reason of best fit here. So what I'm doing, I'm trying to find a reason which one could be the case. So when I was trying to interpret it, I understood that spherical flow may exist. So I just considered the limited entry well, and I have not actually specified anything. I am running a simulation. So model actually gave me the value of 250 feet for HW. So now I'm running, I'm using the same, and I'm now actually trying to improve it. So run it. Now you can see this one is giving me the reasonable fit, but here you can see in last I'm not seeing any fit here, and it is not going to give me the match also. So if you look at the data, it has suggested skin of 3.42. It has also given me the RE value. So this time I also have known the radius. Okay, so I have known this radius also, radius of investigation. So it is giving me the 5000 feet, permeability 0.592, but again, because I'm not getting the best fit, so I can again make the changes in the model, and I can find the if I find suppose some improvement in the graph, some match, so I will take this. Okay, so today why I included this problem, I just hided every information from the data. I'm just trying to tell you that whenever you don't have any information with you, you can actually, it will take more time, but you can run the run different cases over the model and try to find the best fit. If you look at this, this is showing the pressure buildup scan of the two. This one is MTR graph. It's a reasonable match, but in border derivative, I'm not getting a good match. So I will try the another change in the model. So now you can suggest me. It is I think visible to everyone. You can tell me if we can choose any other information here. So based on the first interpretation, I just have chosen limited entry and the circle. If you want, I can again change. So now this is the last class. You suggest me what could be the changes, what could be the possible changes, so that I can have the good match. If you can suggest, just let me know. Anurag said change in RE value. So it means, Anurag, you are considering search change RE. You are considering a closed system. Okay. So what I'm doing actually, decrease value of RE. So RE is here. Suppose we reduce this 2000. And I'm going to improve this. Again, Anurag, I'm not finding the good match. And see, it is even with 2000 RE, it is not going to give you the match. So again, if you want, I can reduce further it this value. If you want, I can reduce it 1000. then generate, then try to improve. In RE, as you said 1000, so I will keep this constant. So I will remove this from the picture. HW, it is suggesting 327, so we will not run simulation over HW also. So keep this as a constant, because now run it. Again, even with 1000, I'm not getting the good match here. Yes, Amir suggested that, sir, should we convolute and smoothen the data? Okay, let us try this also, deconvolution. So I'm using the smoothing factor as 0.2 and run it. So what is it suggesting? It is suggesting like this. So okay. So I have again regenerated the model. I mean, as you suggested. So what I'm seeing different. So let us improve this. Again, nothing has been actually changed. I'm again not getting the match in the LTR region. This one is a problem here. Something is there which we are making a mistake in the model. It is not able to, even if you look at this, even again in LTR region, I'm not finding the match. So it means there is something which I am actually missing. You are also missing. So this one, deconvolution even also has not helped to match with this. So we'll take again the same data. So we will not deconvolute and we'll say the same data. So we'll try to match with the actual graph with our actual data. So first I can improve it without anything. So I'm not going to get again I'm not getting the match here. So let us try the model again. So in model I have taken constant well-bore storage. Earlier I took the actually vertical limited entry case, and then I had taken the homogeneous reservoir, and boundary I am taking circle. So maybe that we are doing some mistake in the model. So I'm going to change something here. Let us try the vertical well instead of homogeneous, because why I am doing this, my gut feeling said this can be a dip also. Instead of IRF, this can be a dip, and it may be the case of pseudo steady state. So instead of this limited entry, let us try the pseudo steady state here. So I'm going with the model vertical homogeneous pseudo steady state, and then let us try the infinite and generate it. No, nothing worked. Even in this model. It's not working. Yeah, I'll try Amir this also. Let us see. Yes, there is a problem in boundary. So let us change the boundary to what? If you want one fault, see the one fault. No, it's not working. So I will see if I can do something with the what intersecting faults. I don't know why it is showing me the this constant pressure slope. This seems to be a constant pressure boundary plot. Again, everyone should agree that there is a problem in the boundary. So boundary we are unable to diagnose clearly. So we can try with what? Let us try vertical well only and pseudo steady state. Yeah, it's giving me constant boundary again. Not a good match. Vertical. Let me draw this again. Model. Find it. Okay, what if we change to changing Valbor storage? Changing Valbor storage. Changing storage. Pseudo dual porosity. And let us consider infinite. In changing Valbor storage, see the model has given this. It is showing me the changing Valbor storage because it's not a changing Valbor storage. It seems to me a good Valbor storage. So again, we can change to its constant Valbor storage. Let us try again the limited entry. Yes, something is good here. Again, I would like to improve this further. Model. It's not working. It is showing me constant. Yeah, Chandras, I'm trying this boundary. Let us take circle. Nothing works. I'll try to open this again. New file. Valbor storage. Let me take this value again. Let us try with this again. So here I can see it's not working. So earlier there was something which we found from the model: constant value storage, homogeneous, and then circle. So this one gave me the at least 1 minute. New 2291. Page one is 500. I'm going to open this again. Let us try one more time. It was 0.14. It was 1. It was 0.806. 0.806. 39. 3.040. 0.08. Raised to the power minus 5. Okay. Extract DP. So this is your DP again. So in this, I have taken the value constant value storage, vertical. I have taken vertical limited entry, homogeneous, and infinite. So let us try this. So instead of infinite, let us try circle. So this was the case where we had at least this best. So far, it is giving me this. This one is the can be considered as the good match. It is what I have taken the spherical flow here, and I have taken circle. But because I have taken circle, so I am not satisfied with the match in LTR region here. So here I cannot see this. So what we decided that then it could not be a circle, though it is matching with the spherical flow, but it could not be a circle. It means it may be another thing. So we thought that we should try the change in the model. So instead of vertical, we will use vertical. Then if it is not homogeneous, then try two porosity. And then again, because it's not circle, then try infinite. Yes. Now you can see from the previous case, something has been slightly improved in the here, because it has earlier it was like this, now it has been slightly raised. So I can again try if it works. Suppose again, let us try again. It is actually fitting here only. So I have tried the boundary also. I'm trying the I'm trying to pseudo steady state. Okay, now what we will do, we'll go with this mole tool and Kiwi graph. So if you look at the Kiwi, it has suggested three possible solutions: two porosity, transient, two porosity. So I have taken two porosity already, but it is also showing the single and intersecting ceiling fault, single or intersecting ceiling fault. Because if you look at the Kiwi graph, this one is the Kiwi graph. It is showing a good match here. So I told you we need not to see this because this is a direct answer. So what we used to do as an engineer, we should try our best so that we can have a good match. So this is the suggestion from the Kiwi. Now, in order to solve this, we can try the change in the model. So what it suggested? It suggested pseudo porosity. Yeah, dual porosity we have tried. So now I can try the another suggestion. It's saying single or intersecting fault. So we can again try this in here. 1 minute. Model. Instead of this, let us try one fault. Okay, nothing actually worked. Let us try intersecting fault and improve it. Even with intersecting fault, I'm not seeing the good. Okay, can we try the vertical limited entry? No, I think earlier was better. So let us try vertical. Yes. My best answer is this, because here I'm having the reasonable match. If you want to see the more good answer, so let us try the infinite. This is also not giving vertical, two porosity, and infinite. This is my best guess for this, because I have tried every case, but it's not working. If you want, I can change intersecting fault any angle, suppose. So this one is not improving further. So instead of this, let us take this pseudo porosity state. It's a two porosity case, as it is going to give the best match, and I'm taking boundary as a infinite. So again, I have generated this. I have tried to improve this. And if you look at the MTR, it is going to give the good match earlier in the ETR, but in MTR, it is giving me a reasonable match, not a very good match. And because of this, again, I can say here, I'm not going to, did we try a single fault? Yeah, Amir said, did we try single fault? Yes, I tried, Amir, this one also. But it's not improving. Again, I can try single fault. It is showing almost the same answer. But this one is the almost a good match up to this point, even in this. So this could be the best, because I can say we also tried the spherical flow, but in LTR with the spherical flow, we were having this graph here. So it has been slightly improved with the pseudo porosity state, and this dual porosity case was also suggested by Kiwi. So I took the help also from the Kiwi. It was also showing double porosity case. So I have taken the same suggestion from the Kiwi, and it is giving me the reasonable match here with this double porosity. And if you look at the model, this would be the best diagnosis of this graph. Okay, because what I have not included, the some information can be given from the other group, like what could be the boundary. So something is there which we are actually not trying to interpret correctly. So some information should be given from the other group so that we can exactly match with this. What we have tried so far, we have considered this as IRF also. I have considered this as the case of dip in dual porosity, fracture is not there, so I have not considered the fracture. I have considered this as spherical flow also. So I had the good match with spherical flow and dual porosity only. But in LTR zone, dual porosity gave me the slight improvement in the match. So therefore, this could be the best diagnosis of this graph. Okay. Anything else, if you want to interact, you can tell me. Because I have tried every case, so if I change more than you have seen, it will show you the very bad match and it will not work out. So I have just uploaded again. Yes, we can do this also. Yes, sensitivity analysis we can do. If you want, we can change, but I think we have tried this also in other cases, like what we have suggested, Chandrahas. Can we do what? 1 minute. We can do sensitive analysis with L and fault distance. So let us take this value of L. So L, the model is suggesting 11445. Tell me, what do you suggest? What could be the L value? The model is giving me L as 1145. So if you want, I can decrease this. Yeah, okay, 100, 200, 500, okay, 100. 200, 300. This one is the sensitivity graph. It is not 1 minute. Let us again improve it. This one is what? EV. Let me do this again. We can try from the top 500, 300, 200, 100, and 10, suppose. So generate it. So this is the sensitivity graph. So it is also showing this. You see, okay, wow, something is problem here, because you can see, Chandra, there are so many lines here. Like this one is blue, yellow, and some lines are overlapped under this. Actually, they are masked by this line. So it is not showing the legend here. It should show the legend also. Like it can, in legend you can see what line represents what value, but it is not showing. But I am telling you, you see, when I change this to 10, the case has become more disturbing. It is now becoming more disturbed here with 10. So again with 200, 500, I'm not seeing any improvement. So we can try other thing, like we did not shift. Yes, Anshul said we did not shift the build-up data initially. Is this can be no? Yes, Anshul, we checked the synchronization. We already checked the synchronization with because it was already synchronized. So I did not apply the time plus match. So it was already synchronized. Okay. If you want, I have some time. Again, if you want, I can change. So here, this is the this one could be the best analysis, so that you can think more and more. And this one is the model. If you want, if you can, if you look at this, these four interfaces where you can make the changes. So if you want, I can again change. But from my, in my own understanding, this information we have tried a lot, and we have applied so many changes in the model. But so far we have understood one thing, that it is the case of the double porosity. It is, I think, correct. It's a dual porosity case. So in dual porosity, then you should know this is not the IRF. This is actually the dip in dual porosity. Then it is going up. We also have tried circle because it was going to give me the 1. It gave me the slope of 1, so I tried the circle also, but it was also not working. So I think this is the dual porosity case, but this is not actually yes, this is not matching actually. That's all. That is the problem here. In model I have taken, let us take infinite. So in infinite, yeah, it is showing me the same change. Now I would like to actually conclude in my own understanding. So if you don't agree, let me know. If you agree, then it's okay. देखो एक चीज मुझे समझ में आ रहा है clearly that we were working hard on this boundary, but if it is the case of double porosity, then this is not actually the boundary, because in double porosity we know that first dip will come, then when we enter from the matrix into the matrix, this transition will actually this is the dip, and somewhere you will have the IRF later. So this is actually not the boundary. Therefore, the changes we made in the model, like circle, fault, intersecting fault, was not giving the best answer here. Now you can say, why then double porosity is also not going to give the best answer? Maybe something, some data is actually the, or maybe the less data is here, and it is not going to give the match here. So I can say this is not the case of boundary. This is the double porosity, and transition is there. So first I have seen the dip, then I will see the IRF. When pressure transient will reach in the matrix, and it will achieve the IRF regime. So it will come later. So this could not be the case of, I think, boundary. This is the case of double porosity. So in conclusion, I can say something is there during the transition. I'm not finding the good match. So this transition is not actually not giving me the good match. Now, if you don't agree with this, or if you have another conclusion or another point, you can let me know. You can discuss. Yeah, what do you agree with the conclusion from my side? Okay. What about Chandras? What about Anshul? Do you all agree? Okay, so this could be the interpretation from my side. And so far we have understood the best fit in the MTR also. So, but something is there which is not helping the model. This may be the data or sensor problem. Maybe, I don't know. We don't know the correct answer. Okay, this is so we have, I think, seen 11 problems of different cases in the well-test lab sessions. So yesterday Krishna, I think, solved 2 problems. So if you have any doubt regarding these problems, you can discuss with me. So this was the last problem. So I have finished this also. In this problem, I actually excluded everything. So I thought we both will make discussion, and then we will see what could be the best diagnosis of the graph. So anything, any question further, if you have, you can ask me, because now tomorrow and day after tomorrow I'll be having the Viva sessions for this lab. So in Viva, because I got to know that in morning you'll have the Viva of the another lab, I think reservoir characterization. So in this lab, I think somebody, yes, Vishnu sir told me that he is going to take the Viva for the first group up to 30. So in my lab session, I will take students for the Viva from 31st. That includes Ajay Meena also. Okay. Then day after tomorrow, he'll be taking the other half and I'll be taking the first half. Okay. So my Viva will start same time, 2 o'clock tomorrow. For the second half, students roll number is starting from 31, including Ajay Meena. Please let me know, is that okay? Because I thought that that will reduce the burden on the first group because they will face the Viva in first half. So in second half, I can include the second group so that first half can prepare and take some time to relax. Amir said okay. Any other student, is that okay? Okay, Chandras, good. So my Viva will start 2 o'clock tomorrow for the second half. The student roll number, I'm again repeating. Roll number is starting from 31, okay, including Ajay Meena. Okay, then, and then I think this, yes, Viva will be conducted through Google Meet. So same time I will share the link. So I would request all the students to keep their Gmail open so that you will just receive, and it will, yes, it will start from the roll number 31. So it will go in sequence. But I would request that you keep your Gmail open so that you just receive the link and then you immediately join for the Viva. Okay, any other question from your side? If you have, you can ask. Okay, if no more question, then okay. Bye everyone. We'll meet tomorrow for the Viva now.